Welcome to another video for General Science. In this video we're going to be discussing stars. So a star is a large glowing ball of gas in the middle of space, just like our sun. Just like our sun, a star generates its energy through nuclear fusion in its core. And speaking of our star, it happens to be the closest star that there is to Earth. It's the only star we have in our galaxy, and the next closest star is called Proxima Centauri. Proxima Centauri is 4.3 light years away. Well, you ask, what is a light year? Well, you got to consider something here. You got to consider the fact that these things are very, very far away from each other. These stars, the space between stars is enormous. It would be like measuring a star, the next closest star, which is Proxima Centauri, would be like measuring the distance from San Antonio to New York and using a ruler and using the millimeter side of the ruler to measure. It's just impractical. It's not, it doesn't make sense. So when you're measuring greater distances like San Antonio to New York, you want to use miles, okay, or kilometers. But when you're talking about space, you want to use something even bigger than miles and kilometers because, again, we have an enormous, vast amount of space between these two stars. So when you look out into space, for example, you see all these glistening stars, and you think to yourself, oh, well, they must be pretty close to each other. But in fact, they're actually very far away from each other. So space, in actuality, is mainly empty space. Now, of course, you have planets and meteors and such that are, floating around. But in terms of stars, there's actually a lot of space in between these stars. They're not very close to each other. So Proxima Centauri, 4.3, 4.3 light years away. And if you look at the position of Proxima Centauri, you'll notice that there's actually a couple more stars that are pretty close to it, Alpha Centauri A and Alpha Centauri B. And those are the closest stars that we have to our own sun in our galaxy. Okay, in our galaxy, if we look at this image here, this is an arm of the galaxy. You can actually, if we didn't have light pollution, we'd be able to see this. But in our galaxy alone, you have about 4 billion stars. Isn't that amazing? That's amazing. 4 billion stars. And when you consider how far away they are from each other, you kind of get an idea as to how big our own galaxy is. It's enormous. So the light year, let's talk about that for a second. Again, this is our measuring stick. This is the unit of measure for, or our astronomical unit, if you recall from the previous chapter. When we discussed the light year, we're talking about the distance that light travels in a vacuum in 1 year. So if we were to shoot out a beam of light in a vacuum, so there's nothing to interrupt it, we just let it go for 1 year, and whatever distance that is what we call a light year, which happens to be, well, here, before I give you the actual distance, just to give you some perspective, in 1 second, a beam of light would travel Earth 7 times around. In case you missed it, let's do it one more time. Ready? In 1 second, light would travel around the Earth 7 times. Just like that. Pretty fast. Pretty fast, pretty cool. So a light year is 9.5 trillion kilometers long. I'm not going to ask you to make sense of that. Again, that's why I use the Earth analogy, so you can get some perspective on this, because trillion, when you talk about numbers that big, you really have no perspective on that. So it's a huge number. And then the next star is 4.3 light years away. So 9.5 trillion times 4.3, and you'll know how far the next star, Proxima Centauri, is. So how is it that we get this measurement, though? How do we know that Proxima Centauri is that far away? Well, we have something called parallax. If you hold up your thumb close to you, hold it up like maybe a foot away, close your left eye. Your thumb is going to have a position. Okay. Now, if you close your right eye and open your left, you're going to notice that the thumb changes position. The perspective is different now, right? That's why we have two eyes. When you have two eyes, it kind of centralizes our perspective. But when you have one eye open and one eye closed, in the perspective, you only get one angle at which you're seeing an object. So the distance, the displacement that you see there, that's called the parallax. Now, the closer that your hand is to your face, the greater that parallax is going to be. But then if you move your hand further away, okay, and you do the same thing, you view that thumb with one eye open, one eye closed, you're going to notice that the parallax, the displacement, is actually smaller. So the further the object is, the smaller the parallax is. Now, as it pertains to Earth and distance of stars, Earth on one position, if we're trying to measure the distance of a certain star that we see in the sky, then we can look at it at its position at one point in the year, let's say the summer, and then in the spring we can take the next position. So 180 days later, we'll take the measurement of that same star in the sky. Okay, but now we're looking at it from a different angle. It's kind of like when you close one eye and open the other. It's the same thing when the Earth is in the different opposite positions. You can take those measurements, and based off of this, you can actually tell, or you can roughly tell how far a star is. And if it's further away, then the parallax of that star is going to be smaller. So we can get a pretty rough estimate as to how far or close these stars are. Alright, well, that does it for our discussion with stars. I hope this helped. When you watch this video and read your text, you should do fine. So good luck in your study.